Hello students, today we will discuss about analysis of variance. Analysis of variance means ANOVA, and in analysis of variance we will discuss one way analysis of variance. So the outline of today's study is what is ANOVA and what is the use of ANOVA. The second point is what are the assumptions required in ANOVA, and third, one example we will consider and we will apply ANOVA through the SPSS software. So these are the three outlines we will study today. The next we will see what is ANOVA. So one-way ANOVA analysis of variance is used to test the claim that the three or more population means are equal. The second point it is saying this is an extension of the two independent sample t-test. So previously we have studied that there are three types of t-test: one sample t-test, independent sample t-test and paired sample t-test. So in all the three types of t-test, the t-test is able to compare the mean of maximum two samples. If we have more than two samples, then combinedly t-test cannot compare the mean value of the samples. So it will can individually two at a time, then second two, then third two. This can do. Suppose we can take an example. If the customers of Mumbai, customers of Delhi, and the customers of Kolkata, these are the three group of customers are there. If you want to compare all the three groups at a time, then the independent sample is not able to do so. Independent sample can do Mumbai and Delhi, Delhi and Kolkata, Kolkata and Mumbai separately. But when we use this one-way ANOVA, it can compare three and more samples at a time. So that's why it is known as extension of independent sample t-test. So in which it analyzes the claim that three or more population means are equal. The second, when we do the analysis of variance, there are certain assumptions are there. The first assumptions, what it is saying, the population normality. What does it mean? So data should be the numerical data representing the sample from the normally distributed population. What does it mean? So the data we collect for the analysis through ANOVA, it should be collected from the normally distributed population. Normally distributed population means if we make the curve of the population, it should be normally distributed, means it should give the bell-shaped curve. So that is the first assumption. Second assumption, it is saying the homogeneity of variance. The variance of the groups must be similar. So the variance of first group, the variance of second group, the variance of third group should be equal. Means all the groups should be homogeneous in nature. Third thing, it is saying the sizes of the groups are similar. If we keep the sample size equal for all the three groups, then the ANOVA gives the more robust result. So if in our group number 1 30 samples are there, 30 sample size is there, then we should keep the in group number 2 also 30 and group number 3 also 30. So the group size should be similar. Then the fourth point, it is saying the group should be independent. Group should be independent. It means that the one group should not be related to other group. These groups should be independent to each other. And the last one, it is saying the residuals are normally distributed. When we find the errors in the ANOVA and the residuals, and when we make a curve, the normal curve should be bell-shaped curve. It should be normally distributed. So before doing the analysis of variance, we must check the data, and the data should fulfill all these conditions. Then our data is correct for the analysis of ANOVA. Also, ANOVA is a parametric test. And which one is a parametric test? At least a test is known as a parametric test in statistics if at least the dependent variable, the response variable, should be in metric scale. That is either in interval or ratio scale. If both are metric, then well and good. But if it is a parametric test, then at least the response variable should be in metric scale. So these are the assumptions of ANOVA. Now this is the basic thing you can see here in the first slide itself we have talked about. So whenever we do any type of analysis, mostly we find there are two types of variable. One is the independent variable, another is the dependent variable. The independent variable is also known as the factor variable or the predictor. The dependent variable is also known as the response variable or criterion. So in ANOVA, the factor variable should be non-metric and the response variables should be metric, and we have already discussed because it is an extension of independent samples t-test, and independent sample t-test is valid for two groups. So when we have three or more samples, we use ANOVA. And what is the application of this ANOVA? It is to compare the means. And one thing we are seeing here, that the one-way ANOVA, then definitely there will be a two-way ANOVA. So what is the difference between one-way ANOVA and two-way ANOVA? So in one-way ANOVA, there is one factor variable and one response variable. One factor variable and one response variable. In two-way ANOVA, there will be two factor variable and one response variable. And the factor variable should be non-metric and the response variable should be metric. Now, as we know that the two types of hypothesis. So what is the null hypothesis of ANOVA? So the null hypothesis of ANOVA is that the means are all equal. So if we are taking the three groups, so the mean value of all the three groups should be equal, then we can say that the null hypothesis is accepted. The alternative hypothesis is that at least one of the means is different. If there are three groups, then if the mean value of group number 1 is not equal to the group number 2, but the mean value of group number 2 is equal to the group number 3, then the alternative hypothesis is accepted. It doesn't mean that mean value of all the three groups should not be equal. If one of the two groups, the mean value of two groups are not equal, any of the two groups are not equal, then we can say that the null hypothesis is rejected and alternative hypothesis is accepted. Now, we are talking about this one example. We have seen what is ANOVA, what is the use of ANOVA, what are the assumptions required in ANOVA. Then now we are considering one example. So what is the example you can see here? Suppose a marketer of a brand of jeans wanted to find out the perception of the customers of Delhi, Mumbai and Kolkata. You can see here there are the three groups of customers, Delhi, Mumbai and Kolkata. So there are three groups. So ANOVA, the first criteria or the assumption is fulfilling here. Now for that, they had conducted a survey in all the three cities and got rating on an interval scale, and the interval scale is a 7-point scale from 1 to 7 from their customer to know the perception of the customers. So here the group, we can say that the factor variable is the place, or we can say that the city, and in city there are the three groups, Delhi, Mumbai and Kolkata. So it is a factor variable, and in the response variable, the dependent variable, that is the response variable, is perception, that is in interval scale. So it fulfills the assumptions of ANOVA. Now they want to do a statistical test to find out if the three set of ratings are significantly different from each other or not. So the most importantly, we can use here the one-way ANOVA because it is holding the assumptions or the conditions of ANOVA. Now we will go to the next part. Now whatever the information we had received, we converted this in the form of a topic. And what is the topic? Perception of customers for a brand of jeans of ABC company, an empirical study. So once we have defined the topic, we have to formulate the objective also, and then accordingly we have formulated two objectives. First one is to study the perception of the customers of Mumbai, Delhi and Kolkata, and second to find and compare the mean values of the perception of the customers of Mumbai, Delhi and Kolkata. Because the objective of ANOVA is to compare the mean values. So first we have to find out the mean values that we have already calculated in objective number 1, and in the second we will compare that all the means are equal or not. Accordingly, our null hypothesis or alternative hypothesis will be accepted or rejected. Now here you can see here the hypothesis. There is no significant difference in the perception of the customers of Mumbai, Delhi and Kolkata for a particular brand of jeans of ABC company. So in the null hypothesis of ANOVA, we have already seen that all the means will be equal. So the null hypothesis, so same thing here it is saying there is no significant difference. And in the alternative hypothesis H1, you can see here there is a significant difference in the perception of the customers of Mumbai, Delhi and Kolkata for a brand of jeans of ABC company. So these are the hypotheses. And for that we have to collect the data and then accordingly we have to analyze, we have to apply ANOVA test and then we'll find out what will be the output. Now you can see here these are the two variables city and perception. So city means the place is the independent variable or you can say that the factor variable, and perception is the dependent variable or you can say that the response variable. Here you can see the one we are putting 1 1 1, it means that these are the customers of Mumbai. And if you go down you can see here 2 2 2, these are the customers, or you can say that these are the responses of the customers of Delhi. Then we will go to 3 3 3, these are the responses of the customers of Kolkata. So these are the three groups of customers. Now one here you can see here in city, so he is the customer, he or she is the customer of Mumbai and he or she has given the responses 2. So response 2 is, it was a 7-point scale. So 1 is equal to strongly disagree, 2 is equal to disagree, 3 is equal to somewhat disagree, 4 is equal to neutral, 5 is equal to somewhat agree, 6 is equal to agree and 7 is equal to strongly agree. So the first customer is disagree. The second customer is somewhat disagree. Then the third one is also somewhat disagree. The fourth one is saying the neutral, is neither agree nor disagree. The fifth one is somewhat agree. So these are the responses given by the respondents by all the three cities. So now we will import this data into SPSS. We will import this data into SPSS. And I have already told you how to import this data in SPSS. We will go to File, we will go to Open, then we will click on Data. We will click on Data. Our file is on desktop. So we will go to desktop. Here is the ANOVA file. And then you have to see it is the .sav format. We have go to the Excel format and then one way ANOVA in Excel file it is there, and then we will open it. Now okay. Now you can see here we have received the data. So in the lower part you can see here data view and variable view. These are the two important aspects of SPSS software. So we'll go to the variable view first. You can see here it is city and it is showing 1 2 3. So it is not mentioned what is 1, what is 2, what is 3. So we'll go to value and we will identify the name 1 is equal to Mumbai, 2 is equal to Delhi, 3 is equal to Kolkata. So we have identified the three cities. And then second, the perception, the data of perception is we have received in a 7-point scale. So 1 is equal to, we'll define it, strongly disagree, 2 is equal to disagree, 3 is equal to somewhat disagree, 4 is equal to neutral, 5 is equal to somewhat agree, 6 is equal to agree, and 7 is equal to strongly agree. So we have put all the levels of perception. Now the city is a non-metric scale, nominal scale. So it is nominal here, you can see in the measure. Then perception, it is an interval scale. So we'll put here scale. Okay. Now we'll go to data view. In the data view, if you click here, you will find out 1 is equal to Mumbai and all this in the string you can find out. Once again you will click it, then 1, it is in the data view. All the numerical values are there. Now I have already told you that in SPSS the main function, main menu bar is analyze. So we'll go to analyze And we know what is the use of application of ANOVA. It is to compare the means. So we'll go to the compare, analyze, and then compare means. And in compare means, you can see here one sample t-test, independent sample t-test, paired sample t-test, and one-way ANOVA. As it is one-way ANOVA because we have one factor variable and one response variable. So we'll click this one-way ANOVA, and the dependent list. What is our dependent variable? That is the perception. And what is our independent variable? That is the CT. So we'll go to the independent variable or the factor variable. Then we'll go and check. It is not required contrast. We'll directly go to the option, and in option we'll find out the descriptive statistics, then the homogeneity test. Two things we will find out, because our one of the assumption of ANOVA is all the groups should be homogeneous in nature. So we'll continue and then click it. Now you can see here. So this is the descriptive statistics, what it is saying, and all the sample size of all the groups are equal. It is another assumption. So you can see Mumbai 31, Delhi 31, Kolkata 31. These are the mean values, the standard deviation, standard error on all the lower bound, minimum value, maximum values are given here. Now the second part, you can see here, test of homogeneity of variance. So in test of homogeneity of variance, it is the Levin statistics test that we do it in independent sample t-test also. So you can see here the significant value is 0.130, which is greater than 0.05. What does it mean? Means the null hypothesis is accepted. Means what? All the groups are homogeneous in nature. So there is no variance in the group. So all the groups has the equal variance. All the three groups has the equal variance. Means the groups are homogeneous. So it holds the condition of ANOVA. Now you can see here in the ANOVA table. ANOVA table you can see here the significant value is 0.000, which is less than 0.05, which is less than 0.05. What does it mean? It means that the significant value, that is 0.000, which is less than 0.05, it means that the null hypothesis is rejected and alternative hypothesis is accepted. What does it mean? It means that there is a significant difference in the perception of the customers of Mumbai, Delhi and Kolkata. But we are not able to understand in which cities there is a difference and in which cities there is no difference. So is there a difference between Mumbai and Delhi, or Delhi or Kolkata or Mumbai? So to know that, we have to do the post hoc analysis. We have to do the post hoc analysis to understand this. So again we will go to analyze, compare means, one-way ANOVA, and then you have to click the post hoc analysis. In post hoc analysis you will go to the Tukey test and then we will continue. Okay, then you will get the result. We have already explained the descriptive statistic, test of homogeneity of variance and ANOVA. So you can see here in the post hoc test. In the post hoc test, what it is saying? First comparison is between Mumbai and Delhi. So what is the significant? That is 0.007. So what does it mean? There is a significant difference in the perception of the people of Mumbai and Delhi. Now the Mumbai and Kolkata. So again the significant value is 0.000. So there is a significant difference between Mumbai and Kolkata also. Same thing, there is a difference between Delhi and Mumbai, that is 0.007, that is we have already discussed here. So it is the same thing coming. Now you can see here the Delhi and Kolkata, that is equal to 0.217. So there is no significant difference between Delhi and Kolkata. Same Kolkata and Mumbai, there is a significant difference. Kolkata and Delhi, there is no significant difference. So this is the analysis of ANOVA. Same thing I have put it in this slide, and you can see here test of homogeneity, what it is saying. So test of homogeneity, the significant value of Levin statistics is 0.130, which is greater than 0.05. It means there is equal variance in the groups. So it holds one of the assumptions of ANOVA. So we can go ahead. The second, in the hypothesis testing, you can see here We have already discussed this. The significant value is 0.000, which is less than 0.05. It means that null hypothesis is rejected and alternative hypothesis is accepted. What does it mean? It means there is a significant difference in the perception of the customers of Mumbai, Delhi and Kolkata for a brand of jeans. Now, if you want to do the multiple comparison, then you can see here the same thing I have copied here. That is the Mumbai and Delhi 0.007. There is a significant difference. Mumbai Kolkata, there is a significant difference. Delhi Mumbai, there is a significant difference. Delhi Kolkata, there is no significant difference. In the red color I have put the significant value. Then Kolkata Mumbai, there is a significant difference. It is less because it is less than 0.05. Again Kolkata Delhi, you can see here same thing it is coming. It is repeating, that is equal to 0.217, which is greater than 0.05. So the null hypothesis is accepted. So what is the conclusion we can say here from this analysis? So the significant value, p value of ANOVA is 0.000, which is less than 0.05. It means that null hypothesis is rejected and alternative hypothesis is accepted. What does it mean? It means there is a significant difference in the perception of the customers of Mumbai, Delhi and Kolkata for a brand of jeans. But in HSD Tukey test for multiple comparison, it has been observed that p value between Mumbai and Kolkata is 0.007, which is less than 0.05, and between Mumbai and Kolkata is 0.000, which is less than 0.05. So there is significant difference between Mumbai and Delhi and Mumbai and Kolkata. But the p value between Delhi and Kolkata is 0.217, which is greater than 0.05. So there is no significant difference between Delhi and Kolkata. So this is the conclusion of this ANOVA. So we have started with what is the ANOVA, then what are the assumptions of ANOVA. We have taken one examples and we have analyzed it in software, and then we have reached to a conclusion. Okay, so this is all about the one-way ANOVA. In the next lecture, we will discuss about the two-way ANOVA.